To produce detailed maps of our continents, it took thousands of years for ancient explorers. Every year we make new strides, challenging the universe with new horizons. In the last 60 years, 5,924 spacecraft were launched from Earth. Many of these spacecraft failed to complete their missions and the connection was lost. Others revealed information that humans had not been able to see for many millions of years. NASA's Voyager 2 spacecraft reached Uranus in 1986. Today I will tell you about what it was able to see in its short journey to the distant planets of the solar system. Voyager 2 wouldn't have made any of these discoveries if it weren't for something that occurred in the 1960s. This was to revolutionize our perception of celestial objects. When Gary Flandreau, an intern at NASA's Jet Propulsion Laboratory, began drawing graphs of future positions of planets in 1964, he quickly discovered that all of the planets outside the asteroid belt were aligned in a narrow section of the sky in the late 1970s. This phenomenon happens once in 175 years in our system. This was an extraordinary opportunity. A spacecraft could perform gravity boost maneuvers to allow it to glide from one planet to the next, thus exploring all of them. This would also decrease the flight time, which would increase the chance of success. This ambitious project was rejected due to high costs. NASA had an alternative plan. In 1977, a more affordable project was proposed, Mariner Jupiter-Saturn 77. Although the probes were designed to only explore Saturn and Jupiter, scientists responsible for their development made sure that they could be used on a long journey. The first probe was able to pass Titan, a Saturn moon with its own atmosphere, thanks to its trajectory. The second spacecraft was also able to fly past Uranus, Neptune, and other moons. It was decided to change its name half a year prior to the launch. The history of space discoveries saw the Voyagers make their debut. It is important to mention that the Voyagers discovered many phenomena in their long history. However, this discovery was confirmed years later. NASA's ambitious experiment made it possible to discover the tumultuous atmosphere of Jupiter, Saturn's changing rings, and Neptune's dark spot. Voyager 2 was launched 9 years ago and became the first spacecraft to reach Uranus. To improve the spacecraft's connection to Earth, two 24-meter antennas and a DSN antenna measuring 64 meters were placed back on Earth. The spacecraft's cameras were expected to be capable of beaming back many thousand images. The Voyager's approach to Uranus revealed some things we knew before that time. These included its rotation angle, 9 rings, and 5 satellites. This information was gathered over hundreds of years by some of the most respected minds on the planet. Only a small fraction of the information available today is due to Voyager's swift flyby. The first navigation images of Uranus's system, taken on June 7, 1985, were captured. However, detailed images were not taken until November 6, when the camera took more detailed shots. It is amazing that the magnetometers remained silent in November, December, and even the first part of January. The Earth's radiation meter slowed down after Mars's orbit, but Jupiter's radio emission continued from the day before the launch. Michael Kaiser, Goddard Space Flight Center, said, "It's either we've encountered an alien planet without a magnetic field, or it's so strange that we don't even know what to look at." Voyager's research has revealed that Uranus's peculiar rotation is responsible for some of its magnetic features. The magnetic dipole is not aligned with the planet's rotation. This is the reason for Uranus's peculiarity. It is actually displaced by 1/3 of its radius in relation to its center. The magnetic axis tilts with respect to its rotation axis at a 60-degree angle. The magnetosphere of Uranus doesn't appear like a large stripe, but rather is lopsided because of the strong tilt between the rotation axis and the magnetic axis. The transmitted images clearly showed Uranus's latitudinal areas on December 27, 1985, dark brown at the poles and light at the equator. Stephen Sinnott, a photographer, was able to confirm that 1985 U1 was Uranus's first unidentified satellite. The satellite was named Extine Puck, a character in William Shakespeare's play. Voyager 2 continued to take pictures of the moons over the next several days, including those known as Titania, Oberon, Umbriel, and Miranda. Their number increased threefold due to the photos. The Voyager 2 team announced that they had discovered 6 additional moons using the photos. U1 and U2 were the largest objects discovered by the Voyager 2 team. U3 was found on January 9th, U4 on January 9th, and U5 and U6 on January 13th. These up-to-date names were used to replace the temporary Uranus satellite designations, 14 Portia and Dubvan Juliet. U3 was discovered on January 9th. U4 and U6 were registered on the 13th of January. The images of January 20th show some details of the relief at the surface of Oberon and Titania. 2 more satellites, U7 and U8, were also discovered, 6th Cordelia, 7th Ophelia. Voyager 2 embarked on its first flyby program, V751, on January 22nd. It took regular photos of the moons and captured the color of the Uranian rings, Umbriel, and other details. Bradford Smith discovered another satellite, 1986 U9, in one of the images taken the next day. It was later named A8 Bianca. NASA's astronauts were amazed by Miranda, or its unusual terrain. Voyager's photographs made it possible to identify it. Miranda's outer crust is covered in crevices and dales, as well as cliffs and ravines. These geological features form a mixture of geological features from various worlds. Based on estimates by explorers, there are at least 10 types of terrains that can be found on a celestial body measuring only 500 kilometers in circumference. You can watch a detailed video of this satellite by clicking on the link. It was then time to find the Uranian rings. Voyager 2 was passing through the planet's rings plane when a large number of dust particles were observed 115,000 kilometers from the planet's center and 60,000 kilometers from the outer Epsilon ring. It looked like a diffuse nebula with a thickness of 4,000 kilometers. Voyager 2 discovered 2 new Uranian rings. The first was between the Epsilon and Delta ones. It was temporarily designated 1986 U1R. It looked very faint in direct sunlight and was only visible by astronomers using ultraviolet detectors. These images show the 10th ring of later Uranus. The entire collection is shown in this image from the bright Epsilon to the faint line of 6th rings. Voyager 2 discovered the second ring, dubbed 1986 U2R. It was only confirmed in 2004. It was 39,500 kilometers from the planet's center. Within 20 years, it had moved beyond this distance and could be found at a distance up to 41,350 kilometers from the core. Voyager 2 captured its final snapshot of Uranus before saying goodbye to the planet and moving on to new horizons. The probe was already 1 million kilometers away at the time this photo was taken. Neptune was yet another mystery in the solar system. This encounter would bring about a significant scientific breakthrough. Thousands of people waited in anticipation for yet another step into unknown territory, even though they were billions of miles away. After a long journey through the vastness of space, Voyager 2 eventually reached Neptune, the outermost planet in the solar system. On August 25, 1989, the spacecraft made its closest approach to the planet, coming within 4,950 kilometers of Neptune's north pole. The images and data collected during this flyby offered invaluable information about the planet's atmosphere, magnetic field, and moons. One of the most significant discoveries made by Voyager 2 during its encounter with Neptune was the detection of the Great Dark Spot, a massive storm system similar to Jupiter's Great Red Spot. This storm, which was about the size of Earth, was believed to be a giant vortex of swirling gases with winds reaching speeds of up to 2,000 kilometers per hour. Voyager 2 also observed the dynamic nature of Neptune's cloud systems, which appeared to change rapidly over short periods. The spacecraft's observations of Neptune's atmosphere revealed that it was composed primarily of hydrogen and helium, with traces of methane giving the planet its characteristic blue color. In addition to studying Neptune's atmosphere, Voyager 2 also provided valuable information about the planet's magnetic field. The spacecraft found that Neptune's magnetic field was both tilted and offset from the planet's rotation axis, similar to Uranus's magnetic field. Among the most exciting discoveries made by Voyager 2 during its Neptune flyby were the detailed observations of the planet's moons. The spacecraft observed 6 previously unknown moons, bringing the total number of known Neptune moons to 13. One of the most intriguing moons observed by Voyager 2 was Triton, Neptune's largest moon. The spacecraft discovered that Triton had a thin atmosphere and an active surface with geysers spouting nitrogen gas into space. After completing its historic Neptune flyby, Voyager 2 continued its journey into interstellar space, where it still operates today, sending back data on the outer reaches of the solar system and beyond. The spacecraft's extraordinary discoveries have not only expanded our understanding of the distant planets, but also inspired countless scientists and space enthusiasts to further explore the mysteries of the cosmos.